All right, good morning, guys. So today we are going to take a look at something new, and that's the concept of what we call slope. It's actually not completely new because when we were graphing lines using a table, I kind of made reference to the change in y when x was changing by a certain amount, and I called that the slope. But now we're going to really kind of spend a couple periods kind of delving a little bit deeper into it. But first, let's review what we did with our last lesson. So we said when we were finding the y-intercept, right, if it was on a graph, we would just identify the point on the graph where the line touches the y-axis. In an equation, though, we said that the y-intercept is the y value when x is 0, which means it's just going to be the constant when the equation is solved for y. And we said we're going to use the variable b to represent the y-intercept. We did that all with the last lesson, right? So the first one is great. It's solved for y. I'm going to say, where's my constant? My constant is -4. So b equals -4. That's about as easy as it gets. Second one is almost as easy, right? Some of us are going to get thrown off by the -5x, but remember that negative, that's 3 minus 5x. That negative means the 5x is negative. The 3 is positive. Positive 3, and then -5x. So my b, or my y-intercept, is going to be 3. What about for the third one? Well, there's no y-intercept. So we said if we really needed to, we can incorporate one, which is 0. But since we've got a coefficient of x but no constant, even without me writing it, we should know that it's going to be 0. For the next one, there's something kind of small that we have to do, right? So it's not solved for y, so we need to add 11 on both sides. So really this equation, when it's solved for y, is y equals 4x plus 11, which means that b is equal to 11. And the last one, there's two things we have to do, right? We have to isolate my y term. That gives me 3y equals 2x minus 6. And I have to divide both sides by 3. So since 2 is not evenly divisible by 3, we're happy to leave it as 2/3 x. -6 divided 3 is -2. And now we've got our y-intercept, which is -2. All right, so let's talk about slope, right? So it's a little bit different remotely because I unfortunately can't elicit responses from you guys, but I'll go by what I've heard in the past, right? So when we talk about slope, I say, what is slope? What do we think of? And someone will say a mountain. Someone will say like a hill, a skateboard ramp. Those are all things that have slope. So slope refers to steepness. And then the next question, of course, is what does it mean for something to be steep? And people start using their hands and things like that, which you guys can't see anyway. So if something is steep, we would say if it's diagonal, if we think about a diagonal line, we'd say kind of like it goes up more than it goes over, right? In other words, this is closer to being flat while this is closer to being steep. And sometimes people will say it's kind of the opposite of being flat, which is actually a pretty good explanation, right? So if it's steep from one point to the next, it goes up more than it goes over, right? Whereas here, from one point to the next, it goes up a little and it goes over a lot. That would be relatively flat. All right, so when we talk about slope, it describes what we call the steepness. And again, steepness is how much it goes up, the vertical change divided by the horizontal change, to be a little bit more technical. And you may have heard this from older siblings, right? Rise over run. What does that mean? Well, how much does it go up? That's my rise. That's my numerator. How much do I go over? That means left or right. That's my run. That's my denominator. Now, when we're talking about real-world problems, we also call it our rate of change, okay? And that's more, we will spend a lot of time, probably a full week, talking about the real-world context of slope, which I think is actually pretty interesting, and even remotely, I think it comes across pretty well. But for now, we're going to just be calling it the slope, and we're going to refer to the steepness of the line. Now, this should all be in your notes. And again, rise over run, that really important concept of how much from one point to another, how much do we go up, how much do we go over. Now we've got 4 types of slope. Okay, and again, this should be in your notes as well. Now you don't need to really do any graphing here. In other words, if I was putting this in my notes under positive slope, I would draw a little coordinate plane like that, and I would do this, right? You're not like trying to identify coordinates on this graph and graph it or anything like that, okay? So again, something like this, what I've got here, this is what I would literally write if this was my notebook. I would write positive slope, and underneath I would sketch a quick vertical and horizontal axis, and I would jot down that line. So let's talk about the different types of slope, right? And then we have another discussion. How would we describe positive slope? And then someone says it's diagonal. And I say, okay, that's great, but negative slope is also diagonal. And someone will say a straight line. We're not even going to talk about that because they're all straight. So we're going to say positive slope. How can you describe it? And someone does something with their hands, and I say, okay, now my eyes are closed, describe positive slope to me, and it becomes a lot more difficult. And eventually we get to a positive slope increases from left to right. So if I have a given point, to get to some other point on the right, it would have to increase from left to right. Then the next question is, what's a negative slope? Well, a negative slope, as we go from left to right, would decrease, right? I would have to go, at some point, go down to get to the next point. So positive slope increases left to right, goes up. Negative slope decreases from left to right. It goes down. Now, again, lines are infinite, so they go up and down, but we're talking left to right. So if you're kind of sweeping your head, as I'm doing right now, from left to right, you would see a positive slope goes up, whereas a negative slope goes down. So here's what we notice, right? If we're talking about quantifying the slope, right, this would be a slope of 1. A slope of 1 means from one point to the next, I go up 1 and I go 1 to the right. That's a slope of 1. Now, anything steeper than that is going to be greater than 1. So maybe here I go up 2 and then I go over 1. That would be a slope of 2. Now, what happens when we start to get flatter? Well, if I start to get flatter, my slope will be a fraction. So maybe I go up 1 and over 3. That would be a slope of 1/3. And what happens if it's even flatter? Well, maybe that would be like a 1/10. Well, then what would logically happen when I get to a line that's perfectly horizontal? That would be a slope of 0. It's not going up, it's not going down, it's just going side to side, left to right, it's horizontal. That would be a slope of 0. And when I tilt past 0, if we think about this as 0, what's going to happen if I go further? Now we've got that negative slope. So all these connections, once you start to really analyze the slope, they actually make a lot of logical sense. Now the last one maybe doesn't, right? Undefined. So we're going to say, well, as the line gets closer to being vertical, the slope increases. So this line may have a slope of like up 5 over 1. And maybe this is like up 10 over 1. But what happens then when we go straight vertical? Well, from one point to the next, let's say I go up 5 and I go over 0. Because I'm not going over at all, I'm going up only. Well, that's a problem, right? Mathematicians, humans, anyone, we can't divide by 0. Our calculators can't do it, we can't do it. You can't take 5 of something and split it up into equal parts of 0. That's what division is. So we say our calculator is going to give us some sort of error, divide by 0 error. We simply say it's undefined. So a vertical line is undefined, whereas a horizontal line has a slope of 0. All right, let's start talking about the types of slope. Well, we just did that, sorry. Let's review the types of slope, and then we'll talk about quantifying the slope, giving it a number. So hopefully this first one we look at it, and we say, well, that's decreasing from left to right, so I would call that a negative slope. And this one here on to the right is horizontal, so that would match up with my 0 slope. And this next one over here is vertical, so we said that slope is going to be undefined. And this one here is increasing from left to right, we'll say that's positive. Right? So that wasn't so terrible. You just really matched those up with the pictures that you just copied in your notes before. All right, so find the slope of the line. Okay, so we said our slope is equal to our rise over our run, which is exactly what we've got here. So I've got these nice 2 points identified, and I need to find out, to get from one point to the other, how much do I rise and how much do I run? Now, I'm going to suggest you always start with the lower points. Now, I'm going to show you also that it's the same, but I'm going to recommend that you start with the lower points. So I'm going to rise, and then I'm going to run, and I'm going to count it off. How much did I rise? 1, 2, 3, 4, 5. So my rise is 5 units. And how much did I run? 1, 2, 3, 4 units. So my rise over run, or my slope, is 5/4. Now, something I should have pointed out that I'm going to point out now. When we talk about rising, there's 2 ways we can rise. We can rise up, in which case the rise is positive. Or we can rise down, in which case the rise is negative, and I'll explain. And the same thing goes for running, okay? If I run to the right, my run is going to be positive, whereas if I run left, it's going to be negative. So it works exactly like a number line, right? On the right, of 0 are positives, and the left are negatives. And the vertical, you can think about it as a thermometer. You can think about it as the y-axis, right? Both of these you can think about as the axes. As I go up from the origin, it's positive, and if I go down, it's negative. All right, so this is a really important concept to have in your notes, that if we rise up, it's positive. We rise down, it's negative. We run to the right, it's positive. We run to the left, it's negative. Which means I could actually find the slope in a different way. If I want to be really difficult about this, I can say, well, why don't I start up here? And why don't I rise and run? So I'm going to say, well, what did I do? I went down 5. So my rise, if I go down 5, is actually negative 5. And then what did I do? Well, I ran 4 to the left. And I said if I run to the left, that's going to be negative. So I ran negative 4. Now what happens when we divide a negative number by another negative number? The quotient is positive. So again, and we should make the connection that these are the same. So I'm going to encourage you, and I'm going to model it this way, to start from the lowermost points and always rise up. But really, you could do it either way. And I'm going to model this one that way as well. So here are my 2 points. So I'm going to rise, and then I'm going to run. Now, what did I rise? Well, I went up 3 units. So that's positive 3. And what did I run? Well, I ran to the left. So that means my run is negative 2. So my slope is negative 3/2. So let's think about the way we're going to write the fraction. If my numerator is negative, or my denominator is negative, it means my fraction is negative. But if both of them are negative, when we divide negative by negative, it's positive. So somebody may write this as 3 over negative 2. Somebody else may start from the higher point and write it as negative 3 over positive 2. But really, the best way to write it is just to write negative 3/2. These all mean the exact same thing mathematically, but generally the way we write the slope is we put the negative outside the fraction. Okay, so negative 3/2. Another connection that we should make is the signs of the slopes. This line is increasing from left to right. We would expect the slope to be positive, and it was. This line is decreasing from left to right. We'd expect the slope to be negative, and it was. All right, so let's take a look at finding the slope of another line that's drawn on the coordinate plane. So my question now is, how is this one different than the previous ones? And somebody says, well, we don't have points. And I say, that's exactly correct. We don't have points. But do we not see points? And we say, of course we do. And then everyone that never raised their hand the whole year starts raising their hand to identify some of these points. And I say, that's wonderful. And we've got all these great points. So how can I find the slope of the line? Well, I can take any pair of points. Now, it's going to work out best if you take 2 points that are closest together, because then you won't have to simplify the fraction. But let's take a look at a few examples. Let's take these 2. I went up 2 and I went 1 to the right. So my rise was positive 2. My run, since I went to the right, was positive 1. My slope is 2. Let's say somebody else wants to be a little bit difficult. They're going to say, let me take these points. And I'm going to say, all right, great. I'm rising up from negative 3 to 7, so I'm rising positive 10. And then I'm running 5 to the right. So what's my rise over run? Still 2. Let's say somebody else wants to do something different. They want to go here and rise 4 and run 2. Still 2. So the connection that we're going to make, guys, is that at any point on a line, any 2 points that you select will have the same slope, the same steepness, because to get from one to another, we go up 2 over 1, up 2 over 1, up 2 over 1. So what happens if I do that 3 times? I went up 6 over 3. What if I do it 10 times? I went up 20 over 10. It's all going to simplify as 2. Okay? Let's do the same thing here. So just thinking ahead, I would expect this line to have a negative slope, right? Because it's decreasing from left to right. So let's identify my points. I've only got 2 of them. I don't have all those choices I have before. After this, the hands that are being raised stop. And we say, well, there's nothing else. And then some really inquisitive minds will realize that we can actually continue this pattern, right? Just like when we were graphing lines using a table, if I go down 5 and over 1, I can go down 5 and over 1 again. But I'm going to hold off on that because we will need to see that soon. So now we're going to say, well, let's measure the slope. Let's find my rise over my run. So my rise, if I start from this point, is that I'm going up 5. So that's positive 5. And I am running to the left, so 1 to the left. So my slope is 5 divided by negative 1, which is negative 5. okay? And if you started at the top point, just to give you a little counter example, what am I doing? I'm rising -5 because I'm going down, and now I'm running to the right. So that's +1, so still -5. But again, I'm going to encourage you to always, and that's the way I'm going to model it, start from the bottom point. That way our rise is always positive. All right, find the slope between these 2 points. Okay, no problem. Let me plot those points and connect them. And let's measure my rise over my run. So I'm going to say rise over run. So I'm going to rise 1, 2, 3, 4, 5. And I'm going up, so my rise is positive, and I'm running to the right, so that's positive as well. 5/2, right? We always want the slope as a fraction. A mixed number is not going to help us. A decimal is not going to help us. Fractions and improper fractions only. That is the only way we'll express the slope. If I see a mixed number or a decimal with your homework, I'm going to know that you didn't pay attention and you didn't watch the video, because that's the only way that we want our slope is as a fraction. All right, let's do a similar one, right? So I've got 4, 1, and I've got 1, 3. So I connect 4, 1, and 1, 3, and I've got a pretty big problem here, right? Actually, I'm sorry. I'm thinking ahead a little bit to another lesson where we have to find the y-intercept. So this is actually still pretty easy, right? 4, 1, and 1, 3. So I'm going to measure my rise over my run. So I'm going to rise up 2, so my rise is positive. And I'm running 3 to the left, and I know when I run to the left that my run is negative. So 2 over -3, we could simply call -2/3. So that's going to be my slope. All right. Also, guys, when we're talking about slope and y-intercept, we said the y-intercept was going to be the variable b. The slope is going to be the variable m. So do we need that for today? Not really, but it's something that I want you to keep in your mind. I want you to put it in your notes here, right? So you have the slope as m. So if you want to express it that way for today, m equals, you can do that, or you can simply put slope. Okay, guys, so there's your now try. All right, so let's see. When we plot those points, I've got -3, 4. I've got 5, 0. And be careful that you put them in the right place. I know some people will do 0, 5 instead of 5, 0. So I'm going to connect my 2 points. And I'm going to rise and run. So I'm going 1, 2, 3, 4. So that's my rise, +4. And now I'm running all the way to the left. So I'm running from 5 all the way to -3. So if I count off from 5 to -3, from 5 to the origin is 5, plus to -3 is another 3. That looks to me like 8, but I'm going to the left, so it's -8. Hopefully we're going to simplify that fraction. So what's 4/8? It's half. But since it's negative, my slope should be -1/2. So I'm going to use the variable m to represent my slope, which is -1/2. Guys, if you put an answer that's positive for a line that looks like this, that's a fundamental mistake, right? Obviously, the line has to have a negative slope. So our slope should be, if you put 4 over -8, that's fine. But really we want to, and I know I haven't done one yet where we've had to simplify the fraction, but we really want to simplify the fraction to -1/2. So directions for the worksheet, that's going to be your homework, okay? For each letter, plot and connect the 2 points, find the slope of the line and write it in the letter, and put the letter in the box at the bottom. If you just have the letters filled out, I'm going to know you didn't do it, right? In other words, yes, you can Google the question and it will give you the answer, okay? That's not what I'm looking for. I don't care really about the riddle. I want to see you draw the lines. So it's split up in 2 parts, the left half and the right half. That's where you're going to, on those grids, that's where you're going to plot the points. You're going to use a ruler to connect them. You're going to measure the slope. I should see all of that on the worksheet, that you're measuring your rise over your run. Any questions, comments, concerns, upload it, post your comment on Google Classroom, and I will get back to you as soon as I can.